So it must be visible. Whether it is visible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So here I have taken I have made one example with the two variables. Say see in variable view that we have put one variable as x and another one as y. So I have given x the name to x as area and say y to yield. So okay, both are numeric in nature. Now come to data view, and one by one we will be doing hands-on. So first we need to calculate the four features which we discussed yesterday: measure of central tendency, measure of dispersion, measure of skewness and kurtosis. So four we will be doing. So see here, to do this, go to analyze, and there are two ways to calculate descriptive statistics. Either you go to frequency or you go to descriptive statistics. So let us do one by one, and we see which one is better for us. So let us go to this descriptive statistics. There you will see you have to put either one variable or you may put both variable here, and then click on the option. So here you will see the different statistics, say mean and variance, range, minimum, maximum, kurtosis, skewness, and just click on continue, and then click on OK. So this way, this output will be displayed. See here, this is the descriptive statistics table. See here, these are the two variables under consideration. 14 observations are there in both the variables. See, this is the range 11, 14, and this is minimum 4 for say x, and it is 8 for y. Maximum is 15 and 22. Here, these are the mean observations, and these are the standard deviations, and this is the variance square of that. And you can see here, this is the beta 1 for x and beta 1 for y, and these are the kurtosis beta 2 for both, and these are the standard error for that statistic beta of 2. This is standard error for beta 1. So this way we can calculate all the, and we can have idea that whether it is going to be symmetric, asymmetric. So we can have idea that it is not symmetric. Otherwise, this value should be almost equal to 0. And if it is normal, then this value should be close to 0 if gamma 2 is calculated here. So gamma 2 is nothing but beta 2 minus 3. So it must be very close to 0. So it is close to normality, but not exactly, but very close to that. So here, let us do it in the other way. That you go to analyze, go to statistics, and go to frequency here. So both variables are here. Go to statistics. Sorry. Go to quartile, and which percentile, if you are saying you wish to know which percentile. So you just say 75 and add this one. Mean, median, mode, sum you need, then standard deviation, variance, range, minimum, maximum, if standard skewness, kurtosis. Then click on continue. If you wish any chart, then you can go for that. Say histogram, then so histogram with normal curve, or you may go for pie chart, you may go for bar chart, or none you can go. Say we are interested in histogram along with the normal curve over histogram, and click on continue, and just click on OK. So you can see here, these are the descriptive statistics for both the variables x and y. See here, mean, median, mode, standard deviation, variance, skewness, and standard error of the same table which we have calculated in other way to going to the descriptive statistics. Now this is the frequency table. You can see the frequency, how many variables are there for both the variable. Now we can see here the histogram, and this is the this is almost normal. You can see but due to this observation, it is not going to be. Here, this is the normal curve and this is actual histogram. You can see here, this is not going to be normal because it is negatively skewed, you can say. No, sorry, it is positively skewed because tail, more long tail will be here, this on this side. So this way we can calculate the descriptive statistics along with different graphs. Now, if we are interested in making, say, another graph, so either you can go for the graph and go to chart builder and you can see different charts. You select for the, you just put here variable and then click on that. Otherwise, you go to analyze and go to descriptive statistics and there go to the frequency and you go to chart. Now we are interested in pi, say, then click continue and click on OK. So the pie charts for different variables will be made. And if you wish to display the percentage here, just double click on it. See, it is showing that, double click to activate. So just click double on it and go to, and just click on this graph, then close. So percentage will be displayed here. So this way you can, now it is, you just double click on that, go to this one. And if you wish to change the, display, then you can have you can put the values as well here. So you have to change this one as per the change. You can make it as per your choice. Okay. So now come to another, say, no, descriptive statistics. Just click on, go to descriptive statistics frequency, and now go to chart and say, suppose we are interested in bar chart, and click on continue and then click on OK. So these are the statistics and these are the bar charts for area as well as for yield. So this way we can, for all 15 observations, you can see these are the frequencies. So this way we can calculate the descriptive statistics and we can make the graphs of these statistics as well. Now the correlation also comes into the category of, descriptive statistics. So we will be calculating the correlation, which we had not discussed yesterday, but we will be calculating. And first thing, to apply these things, how to check the normality of the data, which we had discussion on yesterday. So how to check that? So click on analyze and go to descriptive statistics. Go to analyze, then descriptive statistics, and here you will see that you have one option, that explore. So you have to put both the variables, say here in dependent area, or you just take one variable. You can calculate for both, or for every variables, but just we are calculating, say, for one variable. Then go to statistics, then descriptive statistics, and if outliers, you can put tick on any option. Go to plot. So normality, there is no need of other any option, no histogram, no stem leaf. You just click on normality plot with tests and just click on continue. Option ascending is okay, excluding cases stepwise. And so just click both statistics and plots here. So click on OK. Now you will see these are the descriptive statistics which we have calculated. Now this is the test for normality. So there are two tests which we had discussed yesterday, that Kolmogorov-Smirnov test for normality and Shapiro-Wilk. From both the tests you can see, and the variable yield, the p-value for this variable is 0.2, which is very much greater than 0.05, and it is very much greater than 0.05 for this Shapiro-Wilk as well. So this test is showing that this data y, that is yield, is normally distributed. You can see through this QQ plot that all points are gathered around this line and they are making a very sharp S. So you can see here, this is PP plot. Now come to box plot. There is some slight shift towards this right side. But so here, if you will see this box plot, then we may say that data is not going to be normal. But that is why we should rely on the test. But the test is saying that the variable is normally distributed. So these are the ways to check the normality of the data. Now,
sir, please explain these two types of normalities which you have explained given in the box.
two types of normality. There are two types of tests.
Based upon which we calculate, we decide whether the data is
almost both gives the same result.
Okay. So here the value of P is greater than 0.05.
So data is non-significant. Non-significant means null hypothesis is not rejected, and the null hypothesis is that the data is normally distributed. Okay.
Okay, sir.
So this way you can see this P value, this P value. Now let us calculate since the data is normally distributed, so we will go for there are two ways to calculate the correlation coefficient. One is known as Pearson correlation coefficient given by Carl Pearson. Carl Pearson correlation coefficient, or we call it as Pearson correlation coefficient. Another one is for the non-parametric data, or if we are having the ranks, then we calculate the Spearman rank correlation. So here, since we have seen that the data is normally distributed, so we can go for the Pearson correlation. So you just go to correlate and go to bivariate. Put both variable here and go to Pearson. And you can go for the option as well. Mean and standard deviation you can calculate. Cross product variation, variance, covariance you can calculate. So click on continue and then click on Pearson. Otherwise Spearman or Kendall you can calculate. We are here using the two-tail. Two-tail means the correlation is particular that and it is not equal to that. Just click on OK.
So can you show again, please?
Which one?
Can you run again this test, please? I actually lost my connection in between.
Just go to analyze. We are just calculating the correlation. So go to correlate and go to bivariate. Since we are using two variables, you put both variable here and just click on Pearson. If the data is normally distributed, both the variables normally distributed. If it is not so, go on Spearman rank.
Okay.
And go to option. You can have these options. Otherwise, you may skip and go to this. Click on OK. So you will see these are the mean and standard deviation of the two variables, and these are the correlation. So you can see here Pearson correlation is 0.265. Very weak correlation. And what the significant value is saying that it is uncorrelated at population level. So it is very, very weak correlation. So here the correlation is 0.265. It means there is positive correlation and there is only 26.5% compatibility in both the variables. They are bearing the same nature up to 26.5% only. So now here in
sir,
if you have any query, any question, please ask. Then we will be discussing some parametric test today.
So,
Sir, ये
sir,
weak.
we can
Okay.
tell when do we use paired t-test and when do we use unpaired t-test?
That we will be discussing in parametric test.
Okay.
सर ये जो वैल्यूज आई टू 0.265 तो ये दिखा रहा है कि 26% ही उसमें कोरिलेशन है एरिया और यील्ड में.
वीक कोरिलेशन है, मतलब ये है कि अगर 100 बातें करते हैं तो उनमें से केवल 26.5% बातें उनकी मिलती हैं, बाकी नहीं मिलती.
Sir, is the 0.26 is R value?
R value, yeah.
And do we have R square value also?
No need of R square. R square is needed when you are fitting some curve. That is coefficient of determination. So that is used in regression analysis.
In the SPSS sheet, it is not mentioned R value.
Where not mentioned?
In the SPSS output sheet,
It is
R
mentioned.
value mention नहीं है sir.
अरे है, देखिए.
अच्छा.
ऐसा कैसे हो सकता है? हम आर ही कैलकुलेट कर रहे हैं, कैसे मेंशन नहीं करेगा? ये देखिए पियर्सन कैलकुलेट किया है, क्लिक करिए, यही तो है. ये देखिए कोरिलेशन लिखा हुआ है, दिस इज द कोरिलेशन. किसी वेरिएबल का उसी वेरिएबल के साथ तो 100% होगा ना, तो 1 हो गया कोरिलेशन. ये एक्स हो गया, ये वाई हो गया, यील्ड, इन दोनों के बीच में 0.265 हो गया.
अलग से R नहीं लिखा हुआ कहीं.
हैं?
अलग से R नहीं लिखा हुआ. It is not necessary.
नहीं, आर लिखना जरूरी नहीं है, क्योंकि
अच्छा ठीक है.
नोटेशन डिफर करता है ना, हो सकता है बहुत जगह कंट्रीज में इस तरीके. सो इट इज बेटर टू राइट द थिंग्स इन नंबर.
सर
टू
ये
टेल्ड का मतलब टू टेल्ड का मतलब क्या होगा सर इसमें?
टू टेल्ड का मतलब होता है, देखिए हाइपोथेसिस जो है, अभी पैरामीट्रिक में हम लोग बात करेंगे. हाइपोथेसिस दो तरीके की होती है, वन टेल्ड या टू टेल्ड. मान लीजिए हम कहते हैं कि एवरेज मार्क्स 65 है, ये नल हाइपोथेसिस हो गई, सिंपल है. अब जो कंपोजिट हाइपोथेसिस कह रहे हैं, या सिंपल भी हो सकती है, अल्टरनेटिव में हमने कहा कि हाइट 65 से ज्यादा है, हाइट 65 से कम है, हाइट 65 नहीं है. तो जैसे ही हमने कहा 65 से ज्यादा है, मतलब राइट टेल्ड की बात कर रहे हैं, वन टेल्ड. कहा 65 से कम है तो लेफ्ट टेल्ड और वन टेल्ड की बात कर रहे हैं. लेकिन हमने कहा कि 65 नहीं है, तो इसका मतलब उससे कम भी हो सकती है, ज्यादा भी हो सकती है. तो दोनों तरफ टेल्ड वो क्रिटिकल रीजन लाई करता है.
जी, थैंक यू.
Sir,
हम्म.
to test the normality, there are many tests and also graphs and also the thumb rule, right? Do you have any preference of which one to choose and which kind of data? Is there any criteria like that?
Ma'am, just I have said already, and keep in mind everyone that you have to rely on the test, because behind that there is a rigorous mathematical formula. So don't rely firmly on that 100% on the graphs, but you may rely on the test. As we have seen here that the little bit one whisker was greater than the another one, larger than the another one. So it was showing that it was, one may think that it is skewed, but at the population level or the data is saying that it is normal, because test was saying that it is normally distributed. It was not significant. So
Okay.
we should rely on the test. In nutshell, we should rely on the normality test. That is Kolmogorov-Smirnov test or Shapiro-Wilk test.
Out of those two, if there is a difference in normality, which one should we prefer?
Normal, if it is,
Out of those two tests, Kolmogorov and Shapiro's, if there is a difference in normality, like one is showing normal and the other one is not normal, like which one should we prefer?
yeah, then we should go with the non-normal.
Okay, sir.
It is better to select that than go further. It means there may be some outliers and extreme observations. So better to use non-parametric test.
Okay, thank you, sir.
Sir, if one of the tests is showing non-normality, then we have to go to non-parametric test?
Sometimes we face the problem, yeah, we come across the problem situation where one test is significant and another one is insignificant, non-significant. It means the p-value, one of the test Kolmogorov, Spinov or Shapiro is having its p-value less than 0.05 and one is having another greater than 0.05. So there we should go with the significance one. So we should accept that the data is non-normal.
Sir, is it possible to do Mann-Kendall test in SPSS for trend analysis?
Which test?
Mann-Kendall test for trend analysis.
I have not actually done that. For trend analysis, you can go for the time series data, so it must be there. But
Okay.
for time series, I usually use the either Python codes or that R codes. I have not done that. Let us see whether it is given or not. Go to analyze and forecasting is there. It must be there. In forecasting, you will have. See, go to trend analysis. It must be there. But I have not used that one. Create model, apply model. So you can go for the apply model. Yeah, it must be there. So if you think that it must be in SPSS or not, you just Google it. You will find the solution.
Okay. Thank you, sir.
Sir, can you please show me the option where I can check that if the test is normal or not normal?
That we have done.
Sir, can you show me 1 second?
Click on that analyze and go to this descriptive statistics, and there you will see one option explore.
Okay, sir.
Just click on that. So you can put both here and go to this plot. No need to go statistics, but if you wish, then you can go for the descriptive statistics. Otherwise, you have to go to the plot and leave every option, but tick this one, normality plots with tests, and just click on continue and click on OK. So you will see here. This is for the yield. So see here. This test is for the yield as well as for area. So see here, both variables are put here, and both are showing that both tests are showing that the x and y both are normally distributed because every p-value is greater than 0.05. And you may have idea from these QQ plot and box plot as well. But we should rely on. So this is showing clearly that it is normally distributed, but this is slightly. See, this whisker is lesser than, shorter than this one. So we may say that it is going to be right skewed, little bit, but the test is showing that it is normally distributed. So we should rely on the test. So now,
Okay,
if
sir.
you are not having any query, any question, then we should proceed further, and we will be discussing the non-parametric, parametric tests. अगर अब किसी के पास कोई सवाल ना हो तो हम लोग आगे बढ़ें.
सर कोरिलेशन का यूज कहाँ कहाँ पे कर सकते हैं हम?
कहीं पर भी कर सकते हैं मैम, जहां पर भी कोई दो वेरिएबल में आप संबंध निकालना चाह रहे हैं, बशर्त ये है कि they must have some real association, मतलब स्पूरियस नहीं होना चाहिए. एक एग्जांपल आपको बता दें, हमने कहीं पढ़ा था, किसी रिसर्च आर्टिकल में देखा तो बहुत हंसी आई हमको. सभी लोग हिंदी में कंफर्टेबल है नहीं?
Yes, sir.
Yes, sir.
Yes, sir.
तो वो क्या कर रहा था, उसमें दिखाया था वन हैज कैलकुलेटेड द कोरिलेशन बिटवीन द से मार्क्स ऑफ मैथमेटिक्स एंड द टेम्परेचर एट लखनऊ. तो ये जो सॉफ्टवेयर्स होते हैं, तो ये क्या करेंगे कि वो तो सिंटेक्स एरर नहीं होगी, वो तो कैलकुलेट करके दे ही देगा, बट दैट वाज स्पूरियस कोरिलेशन. इसीलिए स्टैटिस्टिशियन की या जो थ्योरी जानता है उसकी जरूरत होती है, कुछ उसकी रिक्वायरमेंट और एजम्पशंस होते हैं। देयर आर सम रिक्वायरमेंट्स एंड एजम्पशंस। व्हाट आर दोज एजम्पशंस? दैट the two variables are said to be associated or correlated if we do change in one variable, there is change in another variable. अगर हम एक में परिवर्तन करें तो दूसरे में परिवर्तन होना चाहिए। जैसे एरिया और प्रोडक्शन में हमें पता है, अगर एरिया हम घटाएंगे बढ़ाएंगे तो प्रोडक्शन पे फर्क पड़ेगा, है ना। लेकिन टेम्परेचर घटाने बढ़ाने से क्या गणित के नंबर में फर्क पड़ेगा? ये
सर, कोई
नंबर को घटाने
correlation ही
बढ़ाने
नहीं
से
है।
टेम्परेचर पे फर्क पड़ेगा? तो नंबर बढ़ा दे तो टेम्परेचर बढ़ा दे लखनऊ का। दैट इज स्पूरियस कोरिलेशन, है ना। सो जब मैम वाज आस्किंग कि कहाँ यूज करते हैं, तो कोई भी दो या दो से अधिक वेरिएबल के बीच में एसोसिएशन निकालना है, लेकिन ये शर्त पूरी होनी चाहिए सॉरी, कि अगर हम एक में चेंज कर रहे हैं तो दूसरे में चेंज दिखना चाहिए, तभी हम कहेंगे ना एसोसिएटेड, नहीं तो इंडिपेंडेंट है। अरे मार्क्स और टेम्परेचर तो इंडिपेंडेंट है ना, कि डिपेंडेंट?
सर इंडिपेंडेंट है।
हाँ, जो डिपेंडेंट होगा उसी में हम कोरिलेशन निकाल सकते हैं ना। जो संबंधी नहीं है तो कैसे कहेंगे संबंध? सह संबंध बोलते हैं ना हिंदी में।
सर एक बेसिक क्वेश्चन है,
हम्म
जैसे मुझे जो समझ में आया, आपने बताया कि नॉर्मल डेटा है तो पियर्सन कोरिलेशन लगाते हैं,
हम्म
एम आई राइट?
जी।
तो अगर एक डाटा नॉर्मल है और दूसरा डाटा नॉर्मल नहीं है तो भी लगा सकते हैं मतलब?
नहीं, तब हमको नॉन नॉर्मल वाले के साथ जाना चाहिए, यही तो हम बात कर रहे थे अभी।
ओके।
एक मैम ने पूछा ना था कि इसमें से अगर कोई इवन एक टेस्ट कोई दिखा रहा है कि एक जो है नॉन नॉर्मल है, एक नॉर्मल है, तो हमको नॉन नॉर्मल वाले के साथ जाना चाहिए।
जी ओके।
सर
देखिए नॉन नॉर्मल में क्या होता है, देयर आर वेरियस डिस्ट्रीब्यूशंस, है ना। जैसे एग्जाम्पल के तौर पे आपको बताते हैं यूनिफॉर्म, बीटा, गामा, एक्सपोनेंशियल, बहुत सारे पैरामीट्रिक, नॉन पैरामीट्रिक, डिस्क्रीट, कंटिन्यूअस, सो मेनी डिस्ट्रीब्यूशंस। लेकिन हम नॉर्मल को एक तरफ रखते हैं और बाकी सबको एक तरफ रख देते हैं। तो नॉन नॉर्मल अगर है तो वो कौन सा डिस्ट्रीब्यूशन फॉलो कर रहा है, इवन हमको ये भी नहीं पता रहता है। तो इसलिए हमको फिर उसी के साथ चले जाना चाहिए। पता नहीं कौन सा डिस्ट्रीब्यूशन फॉलो कर रहा हो तो नॉन पैरामीट्रिक लगा दो।
सर ये सब तो पैरामीट्रिक में आएगा ना,
क्या चीज?
ये जो नॉर्मल नॉर्मल डिस्ट्रीब्यूशन जो भी हम कर रहे हैं।
वो मैम पैरामीट्रिक लगाने से पहले की स्टेज चेक करने का। अगर पेरेंट पॉपुलेशन नॉर्मली डिस्ट्रीब्यूटेड नहीं है तो हम पैरामीट्रिक टेस्ट नहीं अप्लाई करते हैं, तब हम नॉन पैरामीट्रिक पे जाते हैं। So before applying parametric or non-parametric test, we have to check whether data is normally distributed or not.
ठीक है सर।
उसके बाद ही
सर
अप्लाई।
सर एरिया और यील्ड दोनों मिक्स करके 28 जो 28 आपके पास ऑब्जर्वेशंस हैं, दोनों को मिक्स करके भी वो नॉर्मल कर्व बनेगा?
नहीं, दोनों मिक्स क्यों करेंगे सर?
नहीं सपोज
एक
करो
एरिया
अगर
है,
मिक्स
एक
करके
एक प्रोडक्शन
नॉर्मल
है,
कर्व।
दोनों मिक्स करना ही नहीं है। एक जो है हम क्विंटल में मेजर कर रहे हैं, दूसरा जो है बीघे या स्क्वायर फीट में मेजर कर रहे हैं।
सर कोरिलेशन के टाइम पे कॉन्टिन्यूअस और कैटेगोरिकल वेरिएबल्स का भी कुछ इम्पैक्ट पड़ेगा?
रहता है वो, नहीं कंटिन्यूअस में यूज ही नहीं करते ना कैटेगरिकल वेरिएबल को, तो नॉन पैरामीट्रिक में आता है ना।
ओके सर, ओके।
रैंक्स का इस्तेमाल करते हैं ना उसमें,
यस
यही
सर।
डिफरेंस है। तो सर जो पूछ रहे थे कि दो को मिक्स नहीं करना है, वो अलग बात है कि जैसे दही के साथ जलेबी हम लोग खा लेते हैं, बट द टू थिंग्स आर डिफरेंट।
ओके
Sir, in both the tests, the significant value is greater than 0.05, sir. Hello?
0.05 से ज्यादा है देन इट इज नॉन सिग्निफिकेंट।
Sir, when it is not significant, we accept null hypothesis. No?
हाँ, लेकिन आपको बता
Where
दें
is
कि लेट मी पुट द करेक्ट थिंग, वी नेवर एक्सेप्ट द नल हाइपोथेसिस,
okay, sir.
but we are
It is
bound to accept that one. So statistical in language we write that because we are sitting here, we are sit here to reject the null hypothesis. Professor R.F. Fisher, who is supposed to be the father of the modern statistics, he said that the possibly rejected hypothesis is known as null. तो अगर हमें नल हाइपोथेसिस को रिजेक्ट ही करना रहता तो हम अपनी बात पे कैसे पलट जाएंगे? सो व्हाट वी से, इफ इट इज नॉट रिजेक्टेड, व्हाट वी से दैट वी हैव नो एविडेंस टू रिजेक्ट इट, बट वी नेवर से दैट वी एक्सेप्ट इट। वो इज्जत की बात कह सकते हैं, बट स्टैटिस्टिकली वी डोंट राइट दैट वन। वी से दैट correct thing is that we have no evidence to reject it. Either it will be
But-
rejected or we have no evidence to reject it. मतलब करेक्ट तरीका है लिखने, तो लिख भी दीजिए। बहुत लोग लिखते हैं कि नल हाइपोथेसिस इज एक्सेप्टेड। ठीक है, दैट इज गुड थिंग। कुछ और कि आगे बढ़े फिर हम लोग?
सर आगे बढ़ते हैं,
15 मिनट बचा हुआ है।
आगे बढ़ते हैं सर,
आगे बढ़ते हैं।
क्वेश्चन सबके चलते रहेंगे।
हाँ, क्वेश्चन तो ये चलते रहेंगे 2 घंटे। अच्छी बात है। यू देखिए, हमारे को तो अच्छा लगता है क्वेश्चन के जवाब देना, और जब तक संतुष्ट ना हो जाए तो फिर हम लोगों के डिस्कशन का कोई फायदा भी नहीं है। हर एक व्यक्ति संतुष्ट होना चाहिए। एवरीवन मस्ट बी सेटिस्फाइड।
सर पहले कुछ थोड़ा खुद भी पढ़ेंगे, फिर आपसे कल भी पूछ सकते हैं।
हाँ हाँ, नोट डाउन कर लीजिए। फिर डॉक्टर सुशील जी से कहिएगा तो हम लोग फिर से जो है इसी तरीके की केवल SPSS पे हम लोग एक वर्कशॉप कर लेंगे। और अगर किसी को, हालांकि ये रियलिटी ये है कि ये पॉसिबल नहीं होता है हम लोगों के पास, कह जरूर देते हैं हम लोग कई बार, हालांकि ये रिकॉर्ड हो रहा है कि आप हमको ईमेल करिए, हम जवाब देंगे। कब जवाब दे पाएंगे कई बार, क्योंकि वी हैव सो मेनी अदर वर्क्स, है ना। टीचिंग भी रहती है, रिसर्च भी कराना रहता है, कुछ एडमिनिस्ट्रेटिव वर्क्स भी रहते हैं, बहुत सारा रहता है। बट स्टिल इफ यू हैव एनी क्वेश्चन, ईमेल अस, वी विल ट्राई टू आंसर द क्वेश्चंस। उन्हें ज्यादा से ज्यादा यही पूछ लीजिए। चलिए कोई नहीं, अब हम लोग पैरामीट्रिक डिस्कशन करते हैं, वो भी थोड़ा, क्योंकि ये बहुत लंबा चलेगा, बहुत सारे टेस्ट। सो वेदर इट इज विजिबल?
Yes, sir.
Yes, sir.
This slide is visible?
Yes, sir.
Yes, sir. Yes, sir.
Let me put it on slideshow mode. Slideshow mode पे है?
जी।
Okay. So in parametric test, we are going to discuss one sample test, two sample test, both independent and dependent, and more than 2 sample tests, that is ANOVA, that is, and then repeated measure ANOVA. जल्दी से अब हम लोग बात करते हैं। See, one sample T test. So before going into the detail of different tests, let me put key what are the parametric tests. So in testing of hypothesis, we have a sample. On the basis of the sample information, we try to estimate the parameter in estimation theory. And the counterpart of that is testing of hypothesis. We test whether that estimate is correctly representing that parameter or not. So there are 2 types of these. Since here we have, the results are this distribution on the basis of the sample. So sometimes these distributions are also known as the sampling distribution. Let me put this in this way, that we have a variable, say height, and we are interested in the distribution of, say, average height. So average height, we have taken a sample and we have calculated that average. So that height is varying from person to person in the population, and that has a distribution. That distribution is known as theoretical distribution, जिसमें ये नॉर्मल, पॉइसन, एक्सपोनेंशियल ये सब आते हैं। अब now if we are calculating any statistic from the sample, it varies from sample to sample. अगर मान लीजिए 50 लोगों की पॉपुलेशन, उसमें से 5-5 लोगों का आप सैंपल ड्रा करिए, एवरेज हाइट निकालिए, तो वो हर सैंपल के लिए अलग हो सकती है. तो so it is varying from sample to sample, that their height is varying from unit to unit. So it is having a distribution known as theoretical distribution, maybe discrete, maybe continuous. And here we have taken a sample. There are many possible samples, and the statistic value of statistics is varying from sample to sample. Then it must have some distribution, and that distribution is known as sampling distribution. And there are two types of sampling distribution. One is known as small sampling distribution. Another one is known as large sampling distribution. Small sampling distribution is also known as exact sampling distribution. And this large sampling distribution is also known as approximate sampling distribution. And that is the Z distribution. That is standard normal distribution. And this exact sampling distribution, there are three types of exact sampling distribution, and those are T, F, and chi-square distribution. So now we will be discussing one by one. So here we are going to discuss only T distribution. Every application of T distribution turned into Z distribution if we take sufficiently large sample. See, the large sample is considered if the sample size is greater than or equal to 30. If sample is supposed to be small, if its size is less than 30. If it is equal to 30 or greater than that, that sample is considered to be large. Okay. So here we will be discussing this for this, t-test means we are talking about
sample size less than 30.
Sample size is less than 30. Okay. So, and one more thing, every theoretical sampling, discrete, continuous, every distribution approaches to normal distribution for large sample size. वो नॉर्मल को हर एक डिस्ट्रीब्यूशन फॉलो करता है अगर सैंपल साइज बड़ा कर दीजिए तो. यही रीजन है कि हम लोग कहते हैं ना कि नॉर्मल रहना चाहिए लाइफ में, एंड एवरीथिंग शुड बी नॉर्मल इन नॉर्मल स्टेज. लार्ज स्टेज पे वो नॉर्मल हो गया. ओके, सो देयर आर सम assumptions about the parametric distributions. There are two basic assumptions, very important, crucial and basic assumption. Two assumptions are that the first one is the parent population is normally distributed. It means the population from where we are doing sampling must follow the normal distribution. And the second one is that observation should be independent. It means sample is random. We have taken the sample from the population according to some law of probability. That is random. Maybe equal probability, maybe unequal probability, as the case may be. So now these two basic assumptions are for both large as well as exact sampling distribution. Now come to exact sampling distribution, since we are talking about T distribution. So one more assumption is that sample should be small. Okay, now be very specific for the T distribution. Then one more assumption that variance should be unknown. So there are four assumptions for the T distribution. Parent population should be normally distributed. Observation should be independent. Sample should be small. And fourth one is variance should be unknown. So let us discuss it for the one sample test. Single sample t-test. One sample t-test determine whether the sample mean is statistically different from a known or hypothesized population mean. Suppose we are interested in testing this hypothesis. Say, these are the common assumptions which we have discussed. These are the common rules.
Sir, variance should be known or unknown, sir?
Variance should be
known or unknown, sir?
Parent population should be normally distributed. That is very basic assumption. We are not testing whether this variance is normally distributed or not. We just check the data for the variable, not for the variance. That is another thing. That
Sir, my
there is a
doubt is like sir, in Excel we get value for known variances and unknown variances for t-test now, sir. There
that
we take the value of
that
known.
we check we check their equal variance or unequal variance.
Yes, sir.
There is one test for that is known as a very famous name. I am skipping that Leven's test. So Leven's test is there to check भाई दो ग्रुप है हमारे, so there are two groups whether they are say unbiased or biased, like that. It means it is said that the two groups should not have a very high difference in numbers. Suppose one is having only 20 persons or 20 observations, and another one is having 80 observations. Suppose it is so, then the variability in both the groups should be same, variance should be same. So that is test by the Leven's test. We'll be seeing it in while doing hands-on. Don't worry.
Okay.
So these are the requirement which we have discussed, that it should be normally distributed, and parents should observation should be independent, sample should be small, and fourth one, variance should be unknown. These are the assumptions. Okay, now come to this one. Now we are interested in testing that the mean is particular having this value, say x bar. And the alternative hypothesis is two-tailed here, see. That mu is not equal to x bar. This is two-tailed. Because it may be greater than x bar and it may be less than x bar. If it would have been that mu is greater than x bar, then it is right-tailed. If it is less than x bar, then it is left-tailed. And if it is not equal to x bar, then this is two-tailed. So we will be testing this hypothesis. So here this statistic is made that x bar minus mu upon, this is the standard error. There is difference between standard deviation and standard error. Standard deviation is concerned with the population. That is, it is concerned with the variable. While standard error is concerned with the statistic. So statistics is not, standard error is nothing but it is standard deviation, but of the statistic, not of the variable. So here statistic is x bar, and standard error is concerned with the x. Standard deviation, and standard error is concerned with the x bar. So x bar is the standard error of the statistic x bar. Statistic is nothing but any function of the sample values is known as statistic, not statistics, statistic. Okay. So now how to run it this in SPSS? So go to click on analyze, go to compare means and one sample t-test. So you will see this type of dialog box will be opened there. And you have to put the test variable here and test value here, that is x bar. Suppose we wish to see that the average height of male is 5.6 inch. So you have to put 5.6 here, and the variable actual heights of the sample persons are here. The variable we will put here.
So
Go to option and click on
what we have to put at the test value?
Test value which you are interested in testing.
Okay, so like if there is an average height, that's something I have to add, is it?
Yeah. Suppose we are interested, suppose we have taken a test of you all, sorry, and we are interested that average marks is 65, say. So we will put the test value as 65.
Okay.
So you have to put here height, say, and now we are interested in testing that average height is 66.5. Just click on OK. This is the one sample. This is statistic height. This is number 408 persons, and the average height is 68. Standard deviation, and this is standard error for the mean. Now come to t statistics. See here. One was asking about the variance test. So this is where is Leven's test? not given here. So, okay. See here, the t value is this one, and see p value is 0.000. It means it is highly significant. It means the null hypothesis is rejected. It means the average height is not this one, 66.5. Oh, this is one sample test. So there is no need of testing the equality of variance. There should be at least two groups. So that is tested only for the two group and more. So here we will reject the null hypothesis because the p value is highly significant.
Sir, this test value will always be known to us.
This test
value will always be known by us.
I am not unable to understand.
He is asking test value is always known or not known.
Test value you have to put, always it is known.
Oh.
Otherwise, how you will test?
Okay, sir.
Test value is always known.
और सर ये वन सैंपल टेस्ट है, इसीलिए ये जो सिग्निफिकेंस ऑफ टू टेल्ड है उधर हमेशा 0 आएगा क्या?
नहीं, टू टेल्ड से मतलब ये होता है कि आप ये चेक कर रहे हैं कि 66.5 नहीं है, लेकिन अगर आप ये चेक करना चाहें कि जो एवरेज हाइट लोगों की है वो 66.5 से ज्यादा है, सो दिस विल बी वन टेल्ड टेस्ट, राइट टेल्ड। तो ये सिग्निफिकेंट वैल्यू 0 आना जरूरी नहीं है, वो तो जब रिजेक्ट होगा। मान लीजिए ऐसे लोग हैं वहां उनकी जो एवरेज हाइट 66.5 के आसपास ही सब है, तो ये सिग्निफिकेंट वैल्यू है ना, इट विल बी मोर देन 0.05, नॉट 0.000 p वैल्यू।
Okay.
Now come to independent sample t-test. Similar assumptions are there as we have discussed for that. Uses are to test the equality of means of the two groups. Independent test t-test is commonly used to test the following: statistical difference between means of the two groups, statistical difference between means of two interventions. Similar thing written in another ways. So statistical differences between the means of two changes. So this way, similar requirement is there. And now come to this one. See, the null hypothesis is that the mean of both the groups are same. An alternative we have taken here two tails, that mu1 is not equal to mu2. And this way, this is another way to write the hypothesis that the difference is 0 and difference is not equal to 0. Now this is Leibniz test to test the equality of variances, which we were discussing. Here we take the assumption that the variance of both the groups are same. It means the sigma 1 minus sigma 1 square minus sigma 2 square is equal to 0. The variance of the two is, it means it's not such that sigma 1 square is equal to sigma 2 square. The variance of the two groups are equal, and the null alternative hypothesis is that it is not equal. So Leibniz test will check whether it is going to be significant or non-significant. So this is the equal variance assumed. So there are two things: equal variance assumed, so we will use this statistic, and if equal variance not assumed, then there is a adjustment in the degrees of freedom. Degrees of freedom. What are the degree of freedom? Degree of freedom is nothing but number of independent observations minus number of linear constants. So this gives the number of degree of freedom, and that is used in calculating the tabulated value. But nowadays softwares are using only p value, so there is no need to calculate that one. So okay, now for the equal variance not assumed, we take this statistics because we are not taking the combined variance. But in case of equal variance, we are taking here this combined variance: n1 minus 1 s1 square plus n2 minus 1 s2 square upon n1 plus n2 minus 2. See, we are here, this is the combined variance by combining the variances of the two sample variances of the two groups. But here we have taken independently the variances of the two groups. But the degree of freedom will be adjusted by this formula for not equal variances. So this degree of freedom may come in fraction as well. We will see in example. So how to run it in SPSS? Just click on this analyze the compare mean. There you will see independent sample t-test. So this dialog box will be open. You have to put the test variables here and the grouping variable. See, in SPSS, if you are testing the two groups, so it is not like that. In Excel, that you put observations in one column of one variable and other variable in other column. Here, what we do, we put the values of both the groups in a single column, 1 and 2, and then second column is made as the code, that is grouping variable. So we code 1 for one group and 2 for two group. So that grouping variable will be put here, and you have to define groups. So 1 for one group and 2 for another group. So this way we will do in this.
We can put multiple groups.
Multiple group. If we are putting multiple group, then this is the case of ANOVA. We will be discussing later.
Okay.
वो ANOVA का केस हो जाएगा, है ना। ये देखिए यहाँ पर आपको ग्रुप डिफाइन करना है 1 फॉर, तो वो हम अभी कोडिंग भी करना बताएंगे, हाउ टू फीड दैट इन SPSS व्हाइल डूइंग हैंड्स ऑन, वो हम लोग कल करेंगे। ये सब स्किप कर दीजिए। ये देखिए नॉर्मलिटी चेक करने का तरीका। This is the descriptive statistics. See here. Now this is the basic table t-test. So here this is live-in test. So here equal variance assumed, equal variance not assumed. So here you can see that it is going to be significant. The live-in test is showing that the two groups are not having equal variance because p value is very, very less than 0.05. So we reject the null hypothesis that the variances of the two group are same. तो क्या होगा ऐसे केस में, हम ये वाली रो नहीं लेंगे, we will consider this row last, equal variance not assumed. So we will see the t value, we will consider this t value, this degree of freedom. See here, not equal variance not assumed जैसे आया, देखिए यहाँ फ्रैक्शन में आ गया उसी फार्मूले से degree of freedom, and the p value is even it is significant at that case as well, 0.000. So it is highly significant. It means the means of the two groups are not same. वो रिजेक्ट हो गया।
Excuse me, sir. सर ये लिवेंस टेस्ट को रिक्वायर,
देखिए टी टेस्ट में क्या करते हैं, टी टेस्ट में हम ये मान के चलते हैं, बेसिक एजम्पशन है कि वेरिएंसेस ऑफ द टू ग्रुप्स आर सेम। तो हमें पहले वो चेक करना रहता है कि वो सेम है भी कि नहीं है, तो वो लिवेंस टेस्ट से किया जाता है। यहाँ पर रिजेक्ट हो गया कि नहीं सेम है। जब नहीं सेम है तो ये हम नहीं सेम वाला केस लेके चलेंगे, तभी टी टेस्ट लगता है, बट विद द एडजस्टेड डिग्री ऑफ फ्रीडम।
Levin's test is different from F test.
लिवेंस टेस्ट
Is different from F test.
लिवेंस टेस्ट यूजेज एफ टेस्ट, क्योंकि एफ टेस्ट का ही इस्तेमाल करते हैं ना इक्वलिटी ऑफ वेरिएंस के लिए, तो यूज करता है। दैट मे बी फंक्शन ऑफ दैट some with some modification. Now come to pair t-test, that is dependency.
Can you tell that what is the difference between both the two?
Where the difference between
Levin's test and F test.
F test, Levin's test may use, Levin's has given, Levin's is the name of the statistician में or scientist. उन्होंने एक तरीका निकाला उसको चेक करने का, but it will definitely, it is going to use F test. So F test is nothing but it is the variance ratio. It gives the ratio of the two variances, 2 chi square divided by their respective degree of freedom. So it may be some function of that, or efficiently estimate कर रहा होगा उसको।
Sir, if the data is normally distributed, shouldn't it be assumed that the variance is, we assume the variance is equal?
No, that is not case. भाई नॉर्मली डिस्ट्रीब्यूटेड तो है ही, अगर हम टी पे जा रहे हैं, दैट इज द प्राइमरी रिक्वायरमेंट। उसके बाद देखते हैं कि दो ग्रुप में वेदर द टू ग्रुप्स आर बियरिंग सेम वेरिएंस आर नॉट। एक में जो है बहुत ज्यादा नंबर्स में वेरिएशन एक ग्रुप है, एक क्लास है जिसमें बच्चों के नंबर्स में बहुत ज्यादा वेरिएशन नहीं है, एक है जिसमें बहुत ज्यादा, कोई फेल भी हो रहा है, कोई टॉप भी कर रहा है, कोई बहुत कम नंबर पा रहा है, कोई ज्यादा पा रहा है, देयर इज नो कंसिस्टेंसी। तो इस
सर
तरीके को
वेरिएंस
चेक
इज
करने के लिए हम लोग ये नॉट इक्वल वेरिएंस वाला चेक करके चलेंगे।
सर वेरिएंस, द स्क्वायर रूट ऑफ वेरिएंस इज स्टैंडर्ड डिविएशन।
वो
तो अगर स्टैंडर्ड
both are same.
तो
Actually, we
अगर
calculate the variance. After that, we calculate the standard deviation. But standard deviation is fit with the variable under consideration in terms of the measure. क्योंकि स्टैंडर्ड डेविएशन इसलिए कैलकुलेट करते हैं कि मेजर ना बदले। वेरिएंस में मान लीजिए हाइट आप मेजर कर रहे हैं इंच में, तो वेरिएंस तो इंच का स्क्वायर आ जाएगा ना। तो ऐसा तो हम कहेंगे नहीं एवरेज हाइट इतने इंच है, उसमें वेरिएबिलिटी इतने इंच स्क्वायर है। सो टू मेक दैट एट द सेम लेवल कि डिफरेंस भी उसी मेजर में होना चाहिए, वी टेक द स्क्वायर रूट ऑफ दैट स्टैंडर्ड डेविएशन। तो इट हार्डली मैटर्स। नाउ कम टू पेयर टी टेस्ट। वी टेक द डिफरेंस ऑफ द ऑब्जर्वेशंस। यहां पर एक ही सैंपल पर दो बार ऑब्जर्वेशन लेते हैं, बिफोर एंड आफ्टर। Suppose we are interested in seeing that whether insulin is capable to reduce the blood glucose level or not. So what we will do, we take the measure before intervening that insulin and after insulin, and we'll see the difference. So the mean difference, and the difference should not be, ideally it should be zero if it is not effective. So null hypothesis says that there is no difference. It means drug is not effective. So we take this as statistic and we calculate the difference. See here, this one. You go to analyze, then compare means there you will see paired sample t-test. Click on that. You have to put the two pairs. One observation before that and after that. So one variable will be taken here. Automatically, you just click on here and okay. You just click any variable and click on this arrow. So it will be adjusted here. Another one is adjusted here. And you may go for the option. Otherwise, you just click on OK. You will see the output like that. See the to check the normality. See here, this one. This is the correlation. Weak correlation. It is going to be significant. It means it in at the population level, it is having correlation. And this is the descriptive statistics. Now come to the test. See here, this is parity test, and you can see here, we wish to check the equality of average marks of English as well as of mathematics for a particular group. So you can see here, the p-value is going to be significant. It means the average marks of maths are not equal to average marks of English for a class. And to see this difference, you can have an idea from the descriptive statistics as well. यहाँ देखिए अंग्रेजी में एवरेज है 82 और मैथ्स में 65, तो इट इज हैविंग अ सिग्निफिकेंट डिफरेंस। तो यहीं से आइडिया हम लगा सकते हैं दैट इट इज गोइंग टू बी सिग्निफिकेंट, द हाइपोथेसिस विल बी रिजेक्टेड। Now come to one way. No.
Sir, from observing the p-value, how can I understand that if the test is significant or not?
P वैल्यू के बेसिस पे, अगर P वैल्यू आपका 0.05 से ज्यादा है, so it is non-significant. If P value is less than 0.05, it is significant.
Oh, okay, sir.
तो ये टेबल में 95% कॉन्फिडेंस इंटरवल जो लिखा हुआ है, सर व्हाट डज दैट
वो
मीन?
स्टैटिस्टिक की वैल्यूज इन जो देखिए क्या होता है ना, जैसे मान लीजिए आपने एक सिंपल सा एग्जांपल है, लेट मी पुट दिस विद एन एग्जांपल दैट इफ सपोज वी आर हैविंग अ पॉपुलेशन ऑफ 10 साइज ओनली एंड यू आर टेकिंग अ सैंपल ऑफ 2, तो कितने सैंपल होंगे बताइए? आपका बैकग्राउंड क्या है, ये एजुकेशन का मैथ्स है?
सर मैथ्स तो नहीं है।
नहीं है तो फिर मुश्किल है।
सर एक बार रिपीट करेंगे कि 10 क्या बताया आपने?
10 में से 2 का सैंपल, कितने पॉसिबल सैंपल बनेंगे अगर 10 में से 2 का सिलेक्शन करना हो?
5।
5 नहीं होंगे भाई, बहुत होंगे। अरे
परमुटेशन
Sir,
कॉम्बिनेशन
power
permutation
10, 2 to the
हम
power 10.
पॉसिबल सैंपल्स की बात कर रहे हैं। आप सोचिए, अगर हम 1 नंबर फिक्स कर दें, 1 के साथ 2, 1 के साथ 3, 1 के साथ 4, 1 के
2
साथ
to
5,
the power
1
10.
कोई भी आ सकता है। सो देर आर पॉसिबल,
कॉम्बिनेशन लगाए।
हाँ कॉम्बिनेशन लगेगा यहाँ पर। अगर हम विदाउट रिप्लेसमेंट टेक्निक भी लगा रहे तो 10C2 होगा।
10C2 प्राइस।
10C2 मीन्स 10 इंटू 9 डिवाइडेड बाई 2, तो 45 पॉसिबल सैंपल्स होंगे। 2 से डिवाइड कर दे, 10 को 5 आ गया, 5 इंटू 9 तो 9 पंजे 45, 45 पॉसिबल सैंपल्स होंगे। अब आप सोचिए स्टैटिस्टिक की वैल्यू कैलकुलेट करेंगी मैडम तो कितने आएंगे? 45 पॉसिबल वैल्यूज। अब 45 पॉसिबल वैल्यूज आएंगी, उसके लिए हम लोग ये कैलकुलेट करते हैं कि अगर हमने कहा 95% कॉन्फिडेंस इंटरवल, इसका मतलब 45 का 95% निकाल लीजिए। वो उससे जो स्टैटिस्टिक की वैल्यू कैलकुलेट करेंगे ना, उस पॉपुलेशन से निकाल के, वो इन दोनों इंटरवल के बीच लाई करेगा। कभी आपने सोचा व्हाट इज द मीनिंग ऑफ 95% कॉन्फिडेंस इंटरवल? इट मींस अगर 100 सैंपल ले रहे हैं, 100 में से 95 की वैल्यू इसी के इंटरवल के बीच में लाई करेगी। 5 केवल इतर हो सकते हैं, कम ज्यादा। और परसेंट में लिखना है क्योंकि एवरी टाइम 100 सैंपल तो होंगे नहीं, तो परसेंट में जितने भी पॉसिबल सैंपल्स हैं उसका 95% सैंपल्स निकाल लीजिए। उससे जो स्टैटिस्टिक की वैल्यू कैलकुलेट करेंगे, दैट विल लाई इन दिस इंटरवल। दिस इज द मीनिंग ऑफ 95% कॉन्फिडेंस। डाउट क्लियर हुआ नहीं?
Sir, is it somewhere related with level of significance?
लेवल ऑफ सिग्निफिकेंस, हाँ कह सकते हैं।
कह
5%,
सकते हैं।
5%, दैट इज 1 माइनस अल्फा। वही तो
Yes, sir.
कॉन्फिडेंस कोफिशिएंट कहलाता है। 95% हो
Yes.
जाएगा अगर अल्फा 5% रखते हैं, तो दैट इज
Okay.
काउंटर पार्ट ऑफ दैट। 5% इज रीजन ऑफ रिजेक्शन एंड 95% इज रीजन ऑफ एक्सेप्टेंस, जिसको हम कॉन्फिडेंस कोफिशिएंट कहते हैं, 1 माइनस अल्फा।
एक्सक्यूज मी सर,
बताइए मैम, बताइए।
डिग्री ऑफ फ्रीडम सर, ये जो डीएफ है डिग्री ऑफ फ्रीडम सर, इसका सिग्निफिकेंस क्या होता है?
आपने बचपन में कहानी सुनी है कि एक राजा के यहाँ संतान नहीं हो रही थी, उनके यहाँ एक फकीर आए। उन्होंने उनसे कहा कि सुबह उठो, पूरब छोड़ के चाहे जहां चले जाना, 3 दिशा में। तो डिग्री ऑफ फ्रीडम कितनी हो गई?
सर 3, मतलब जो
हाँ,
बेस्ट आपके पास डायरेक्शंस बची।
4 - 1। तो डिग्री
जी।
ऑफ फ्रीडम का मतलब होता है नंबर ऑफ इंडिपेंडेंट ऑब्जर्वेशन माइनस नंबर ऑफ लीनियर कांस्टेंट। वहां पर फकीर ने एक रेस्ट्रिक्शन लगा दिया कि पूरब साइड नहीं जाना है, तो वो 3 साइड जा सकते हैं। तो दैट इज 4 - 1, 3 डिग्री ऑफ फ्रीडम,
थैंक यू सर।
है ना। और इसको जो है, जो कैलकुलेटेड टैबुलेटेड वैल्यू कैलकुलेट करने में इसका इस्तेमाल होता है। सिग्निफिकेंस ये है उसका।
सर